Welcome to my capstone project. This is a model of the Gungnir 120R PC case by MSI, modeled using FreeCAD, a community-made software. At first, I started with a simple box, then proceeded to add feet to the bottom. I made two of these feet, then experimented with mirroring, finally deciding to do a linear pattern to complete all 4 feet. I then chamfered the edges at 45 degrees. While completing the build, I used a ruler and tape measure to take accurate measurements. While I should have done this originally, I hollowed out the main body to create a cutout version of the case. Next, I sketched the hexagonal shape of the airflow holes. I pocketed the hexagonal sketch and then used linear patterning in 2 dimensions to make an array of these holes. This created a 54 by 18 pattern for a total of 972 instances. I then repeated this for the alternating holes, for a total of 1944 instances. Unfortunately, this caused FreeCAD to crash. FreeCAD is a single-threaded software and doesn't handle large arrays well. Although I was finally able to make it render, any edits I made to the body would take a long time to render. So I was forced to scrap this design and moved on. A big part of this project was learning not to dwell on failures like these. Although disappointing, every time I failed, I also learned something, a new skill. For example, I had mastered the linear patterning tool and could make arrays easily. Some complex sketches like this took a long time to constrain, because I had to take a ton of measurements. You can see I am using dimension, parallel, and angle constraints. I want these pockets to be as accurate as possible. I am adjusting the positioning of this sketch on the face. Do you see that dotted line at the bottom of the face? That is linked external geometry. Keep in mind that this video is sped up 50 times, so you can understand how long it takes to constrain some of these complicated sketches. Now this is an example of a hollow pad, for which I had to draw 2 sketches, one on the outside face of the body, which I would pad, another on the inside face, which I would pocket into that pad. I then started working on the power supply case, which was difficult because it resides inside of the main frame of the case. I had to take many measurements inside the case, and it was difficult to get the ruler to fit a lot of the time. Here you can see me working on a sketch for a pocket to be taken out of the power supply case. I am working with fillets and chamfers on the edges. You can see in the top right of the shape, I made a chamfer and then filleted the edges of that chamfer. Now that's all that's left to do is the front of the case. The front of this case is very tricky because it uses faces that aren't aligned with any of the common axes, like the XY axes. So I had to use chamfers and datum planes to create these angles. I used chamfers with angle constraints for the main faces on the front. The reason why the front part of this case is so complex is only really for looks, not functionality. Most case designs use a flat front face, and I'm finding out why now. This part of the build was extremely frustrating and slow, and MSI decided to make my life quite difficult in this regard. I then created a datum plane, angled 10 degrees around the y-axis, and then sketched on that datum plane. I quickly found out that linking external geometry will make your life very hard when doing this, so I had to eyeball this sketch and then use block constraints to define it. I then used a new tool called Extrude to create a new body inside my current one. I made an extrusion with the sketch, then used the cut tool to remove material from the main body. This lets me remove material along any line. Whereas Pocket only cuts perpendicular to the sketch. And with that, I present to you the MSI Gungnir 120R PC case CAD model. This was modeled by Oliver Watt using FreeCAD, a community-made computer-aided design software. I hope you enjoyed my recap of this journey, and thank you for listening.